the attacker can control the user's machine, own the user's machine. So you might wonder why the Microsoft engineer used the ulong to ulong function to fix integer overflow, and not just comparing some like integers. It was because it is recommended by SDL. Like a ulong to ulong API is actually converting 64-bit integer to 32-bit. But it fails if the original 64-bit value is greater than maximum 32-bit value. So any value that is greater than 32-bit maximum value will not be converted. It will just return error. So they are fixing the problem just calling this API. They don't need to like use like comparing the integers or something like that. They just need to use this API. So whenever they fix integer flow, then they will probably use this API because it's recommended in their guideline. So maybe you can just use this as a kind of signature to like find any kind of integer flow from like a Microsoft. So you might wonder, from the list of the functions that has been modified, that patch, they only talked about like one or two, like CPOP3 and Imap, but it actually shows a lot of like meaningful entries here. So you might wonder, they might be hiding something here. So I just digged into more, and looks like the other method, the next one, like a CImap for agent. Here, resize message sequence number table is fixing same problem. It's calling, the old one was just calling the memory allocation routine, but the patched one was calling ulong to ulong, just as they fixed the other integer flow. So it looks like whenever they find some integer flow from their module, they are fixing same kind of problem from other code parts. So that is not related to each other, but looks like the actual programmer that is responsible for that code just learned that kind of technique, or he might not know about integer overflow before, and somebody reported, and somebody like from the security team, maybe they talked about it, and he's educated maybe, and he fixed the other problems with other parts of the code that has same problems. So he fixed the code in other parts with the same method. He's calling ulong to ulong to fix some integer overflow here. So this is a very interesting bug, because it's very hard to exploit. So looks like the server, the fake Imap server, should return like more than like 1 gigabyte of data to maybe a few gigabytes of data to the client. So it's not likely to be exploitable, but it's still like a security problem. So looks like they fixed it for their reason, but looks like they don't talk about it. So they just fix it, but they just don't talk about it. So, and let's see next example. So next example is about the use after free bug. Usually this is very popular in the Internet Explorer these days. And I found that I diffed patch for CV 2010-0249, and I found that they are using a lot of code to replace PTR. So it's small here, but actually the red box there is containing some replace PTR code there. So this is also that pattern happens a lot in the code. So left side is the original code, and right side is the patched code. So they are calling replace PTR. So this is the reference, cross reference from like unpatched code, and replace PTR is called only from 6 places, but from the patched code they are calling a lot of replace PTR. So it looks like they are all related to some kind of event processing. So I looked into replace PTR function. So looks like it's just about replacing pointer. So the name tells everything. So it's just about like a replacing pointer, and looks like the old code was like now replacing the pointer for some reason, and it made like some problem like a use after free, because the like invalid pointer was still there and it was now replaced for some reason, and yeah, it was causing the kind of use after free. So maybe you can use a replace PTR string as a kind of signature for like a future same, if someone just finds the same bug, maybe they will use same like a replace PTR to fix that kind of problem. So maybe you can use that API as a kind of signature for like that problem. And there are other things I found, like the original one, it's a method inside the C markup, and it's a destroys play tree or something like that. And actually the original one looks like the name implies that it's destroying some like a memory structure or something, right? So the original one was just calling memfree, so it's just destroy the memory whenever it's called. But the patched one is calling C3 node release method. And if you look into that method, if you can read some disassembly, then you can know that it's doing some kind of reference count check. So it's decreasing the reference count, and if the reference count is not 0, they just return and looks like somebody is still using me or something like that. So it will not free the memory. So when the reference count reaches 0, then it will free the memory. So looks like, as I told, maybe you can use replace PTR or memfree or other patterns for like a use after free bug. So let's talk about another use after free bug. Actually, this is the number is CV 2010-0806, and actually this vulnerability was used for like attacking Google. So it was like a few months, like almost 6 or 7 months ago. And if you look into, maybe some of you already look into this exploit code. So it's from the wildlife exploit code. I just guess take out some very important part. And if you look into that, it's adding some behavior here, the default user data. This is a very important keyword here. It's adding some behavior called the default user data. If you look up MSDN, it will show every like behavior that is available for Internet Explorer. So this is one of them. So the attack only meant for this behavior. So you must use this string here. So, and it's setting attribute, and this is the key. The S is the key here, and window is the value. And in place of window here, it's meant to use some string here. So you are like setting some attribute using some string. But in this case, the attacker was setting attribute using some object. And it's a very serious problem here, because let's see this first. If I diff the patch, you can see that they patched 2 methods here. And both of them has same patterns inside it. And the pattern is like this one. There are some change inside the variant change type EX call. And the original one, the variant change type EX takes a first and second argument, and first one is destination, and second one is source. So they are just changing the type of variant object, variant type variable from source to destination, and they are using same one, and it will destroy the original like data, and it will cause the use after free bug, and they are fixing it by just using different argument for destination. So they are just allocating some local variable, and they are using it for like a destination for variant change type EX. So this is a very good example, because I never knew about this variant change type EX issue before I diff this patch. So you can actually learn something from the patch, because now I know that variant change type EX can cause some kind of memory corruption error. So maybe if I do some kind of other like a code auditing or something, something like that, then you can use use this knowledge for like that kind of stuff. So in this case, there are very interesting stuff here. Because there were only one exploit out there, but they patched two methods. So what does it mean? It means that they patched something silently without letting people know. So I tracked down the one method they patched was cPersist user data, which probably linked to related to that, what is that, default user data behavior. But the other one was cPersist data peer. And I traced back where that like class is used, and actually it was used by default save history and default save snapshot behavior. So I could create some other exploit using that knowledge just in like a few hours, because I need to figure out how to use that behavior. I grabbed some examples from the internet, and I just changed it to use some set attribute for like a document or window object, not something not string. So it was like a very easy create new exploit. So I think no IPS or IDS have that patterns inside them. So somebody is very like a malicious intent, then they can just create some kind of this exploit and they can evade the IPS because they don't have the like patterns inside them. So this is some kind of, but this was patched like almost half year ago. So I think yeah, I think it's okay. Or something like that. So in this point, there are something to think about. So probably MS could just release that information. Like we also have like a default save history, and we also have some problems inside the default save snapshot. And also, as I showed, like we also have some problems inside the Imap client, and it will overflow if the attacker returns a lot of entries. They could just write about that in the first place, but looks like they didn't do that. So even though they are trying to provide some programs called like MAP, M-A-P-P, looks like they are missing some information for some reason, maybe intentionally or by mistake or something like that. So looks like it's not a good like good behavior, like from like because like what is that, the security vendors should diff all the binaries themselves. Even though they have map, they can't trust the map because map doesn't include some valuable information for sometimes. So I showed the first one was caught by Core Impact a few months ago, and I showed two examples here from Microsoft. I only showed two, but I might find more if you look into more like patches. So it's a kind of just problems for security vendors not having the full information. So let's talk about other things. So this is about exploit spotting. So there are some other problems, like even though you have diffed entries, so exploit writing might be very hard, because something like Adobe Acrobat, I did test with some Adobe Acrobat patches, and just I said it will generate a lot of patch to list or something like that. I used like a cool type example here, and it created like more than 20 or 30 entries. So actually they said they patched just one one vulnerability, like a CV 2010-2204, and I used some public exploits out there, and I pinpointed the exact function that was patching that problem. So it is this entry here, the red box here. This one is actually that one, CV 2010-2204. Then how about the others? Like looks like they fixed a lot of problems, the other problems here. So looks like they might have found similar problems in other code, and looks like they patched it. So with the original exploit code from the like exploit DB, you never hit the other like functions. So how can you hit other like functions, and how can you make an exploit for them, even though you don't know anything about cool type.